In section 9.5, number 15, we're asked to write the equation of a hyperbola, and we're given the asymptotes and the focus. Now, if you flip over to page 428, and you look at the formulas they give you for these hyperbolas, we can figure out how to get this equation. Because if you think about it, what we need is we need to know what direction this hyperbola opens up. Is it up and down, or is it left or right? And that will help us know which is the positive term or the negative term, whether to make y squared positive or x squared positive. And if you look at your equations for your asymptote, they're either b over a or a over b. And if we can figure out how this opens up, we'll know which one to choose. So really, the place to get started is to look at the focus, the foci. The foci are at 0, square root of 13, and 0, negative square root of 13. Now, what that tells me is the y-axis is my transverse axis. It means that this thing is going to open up and down. And if the y-axis is the transverse axis, it means that the y term is going to be positive. So I'm looking at the equations, y squared over a squared minus x squared over b squared equal 1. And all that so far has come from just looking at the foci because they lie on the transverse axis. Now, in this section, all the hyperbolas have a center of 0, 0, so we don't have to worry about that. We don't have anything adjustments to make to our equation. And we know our c term is square root of 13, plus or minus square root of 13. I don't think we're going to need that, but I'm going to write it down because the focus is 0c. And if you look at it, we have our asymptotes. And because we know that we're dealing with that second equation in that gray box, we know that our asymptotes are in the form plus or minus a over bx, since the y squared term is positive. So since our asymptotes are 3 halves and negative 3 halves, that means that the numerator 3 is my a, and the denominator 2 is my b. So all I have to do to write this equation now is go, okay, well the asymptotes told me my a and b. The focus helped me know it was open and up and down, and it told me which equation to choose. So now all I got to do is put the a and the b in, and I'm done. Okay? Now, if you remember, your a term with a hyperbola goes with the positive term. So this 3 here is going to go with the positive term, which we determined was y squared. So this is going to be 3 squared, and that means the 2 squared goes over here. So if we simplify that, we get our equation, y squared over 9 minus x squared over 4 is equal to 1. So the focus was the key to start to unravel all this. In number 19, we're given an inequality, and we're asked to graph it, okay? So if you're thinking about what to do here, you're first going to graph it as if it were y squared minus x squared is equal to 4. That's how we have to think in order to get this going. So y squared, how did that, I don't know, but it's okay. Y squared minus x squared is equal to 4. But we know that with these hyperbolas, we're supposed to have a 1 over here where we have a 4. So how are we going to get it there? Well, we're going to divide everything by 4 to get the 1. So everybody gets divided by 4. Okay, so we end up with y squared over 4 minus x squared over 4 equal 1. And we're supposed to graph this. All right, I'm going to have to pick a thinner pencil here. Okay, so if you look at this, this means since our y squared term is positive, our hyperbola is going to open up and down because the positive term tells us what axis the hyperbola is going to open on. And if you look at this, it's kind of interesting. Both the numbers on the bottom are 4. So this is going to be 2 squared, and this is also going to be 2 squared. So if my center is at 0, 0, and I'll put it there, I'm going to count 2 up on the y-axis and 2 down on the y-axis. And then on the x-axis, I'm going to count 2 over and 2 over. And if you remember what we do, let me make kind of red boxes. We make a box next. We make it kind of longer than we think we need it, just because those are going to be our asymptotes, are going to help us draw our asymptotes in a minute. So we draw it through those vertices and covertices like this. And then the next thing we do, and I'm going to do this in a green color, we draw our asymptotes in. And to get to our asymptotes, we take the corner of those boxes. I'm going to put little dots on each corner as I do it. And we draw a line that goes through those corners and through the center. So there's one asymptote. And then let's do the other asymptote. We'll go to the other corners of that box, that red box that I drew. And we're going to go through the center again. There's our asymptotes. We're almost done graphing this, at least the equality. Now I'm going to make the vertices orange here. This thing opens up and down because the y term is positive. So if I'm going to graph it now, and I'll graph it in black, I'm going to start at the vertex and I'm going to approach each asymptote. But before I do, I'm going to take a minute to look up here at the inequality sign. It is just a greater. It is not a greater than or equal to, is it? That's not what we have. So when I go to draw this, I want to draw it with dashed lines, not solid lines. So I'm going to try to be careful about that. So we draw it and we make it approach the asymptote, but we just have to draw it in dotted. Okay, that's not great, but it'll do. Okay, and then I go down and do the same thing with the bottom one. It's a lot easier to do this when they're solid, especially on the iPad. We make dotted lines. We make them approach the asymptotes. So that black that I drew is actually our graph. I'll need to put little arrows on the end of everything to show that it continues forever. Okay, so we got the thing graphed. Now we have to do the shading, and it's y squared minus x squared is greater than 4. Now, it's kind of weird here. Do we want to graph inside this hyperbola or outside? To me, it's kind of harder here to get a sense of where do you shade inside or outside. So one of the safe things to do when you're not sure, I'm going to hit my yellow button here. I'm going to pick a point that's easy to plug in and see if it works in the equations. Let's pick one like right here, 0, -5. I'm going to plug in 0, -5 into the equation and see if it works. If it works, I'm going to shade there, and if it doesn't work, I'm going to shade outside the hyperbola, okay? So let's see, it's y squared minus x squared greater than 4. My y is -5, and then my x is 0. Is that greater than 4? -5 squared is 25, minus 0 squared. Okay, I kind of messed up. It was y squared minus x squared greater than, what was the question? Greater than 4. I did something and it messed the recording up, but we can keep going. We were trying to decide whether to shade inside the parabola or outside the parabola, and I picked the point -5, 0, which was inside the parabola. So if y is -5, I'll do this again, and x is 0, let's see if this is a true statement. -5 squared is 25. 0 squared 0. Is 25 minus 0 greater than 4? Yes, because 25 is greater than 4. So where I will shade, and I can't really go back to my graph since I've messed up, you're going to shade inside the hyperbola. And what that, because that's where that point was inside the hyperbola. And if you think about it, I'll just draw a rough graph here. Like here was my axis, and I had something like this going on. I had like something like this and something like this, okay? Just generally. Since I picked the point 0, -5, and it worked in the equation, it was inside the hyperbola, what I need to do is shade this part here on that drawing, on your drawing, and then this part here. I'm not going to go back and really be real. I'll just do it this way so you know where to shade. Because if you pick a point and it works in the equation, that's where your solutions are, so you should shade there. And we're done.